this little tiny group that we have here. We're delighted to have you. We're running out of chairs and running out of replacement chairs too, but that's the kind of problem we love having. This is the first of the climate forums to be held here in the Pinery Room on the fourth Thursday of the month, and there will be others all the way through October. The idea is to provide some educational opportunities for folks about climate change and various aspects of it. And I'd like to thank the various organizations who are making this event and the other 9 events possible. So I'm going to ask that if you're a member of that organization, as I read the name of the organization, that you raise your hand so people know if they want to talk with you about the organization, who they could talk to. And the first of these is the Stevens Point chapter of Citizens Climate Lobby. Hands up, hands up. Okay, great. Hands down. Aldo Leopold Audubon Society. Hands up, hands up. Great, thank you. 350 Stevens Point. Okay. Interfaith Community for the Earth. Okay, half dozen of us. Frame Presbyterian Church Green Team. There are 5 or 6 of us. And there are other groups who are going to be joining us in sponsoring forums in future months, but that's the group for this month. So I'd like to have a round of applause for all of our sponsors. I would also like to have a round of applause for the person who conceived the idea of these forums and is devoting a great deal of her time, of her money, and of her baking skills to them. Maureen, would you raise your hand, please? It is my privilege today to introduce our speaker, Dr. Alan Haney. As many of you know, he has served as the Dean of the College of Natural Resources at the University of Wisconsin-Stevens Point. He's also taught ecology-related courses for 40 years and has published 12 books, one of which is Backyard Wonders, which looks like this and is for sale over at the Schmeekley Reserve Visitor Center if anybody would like to pick up a copy. And another of which is titled Jewels of Nature. And the subtitle is Delightful Birds I Have Known. And gorgeous illustrations in there and some wonderful stories. And if you're interested in that, you might talk with her and she will be glad to talk with you about it. If you decide to buy a copy of it, all the money would go to, all proceeds go to the Audubon Society, Aldo Leopold Audubon Society. All right. There's a lot of things, much more to be said about Dr. Haney's accomplishments, but I'm going to guess that you'd rather hear Dr. Haney talking about birds than you'd like to hear Dan Dietrich talking about Alan Haney. So I ask you all to join me in welcoming Dr. Alan Haney.
Thank you, Dan. Well, it's great to see so many of you out on a snowy night with weather and climates changing as they are. But it's great to have you here, and I appreciate your attendance. There will be time for questions. Don't hesitate to interrupt if something really hits you that you want to know about. You can't wait. But at any rate, if you really have a compelling question that you just can't stand to hold it, just shout it out or raise your hand. I'll try to recognize you as we go through. Otherwise, there'll be time for questions and some discussion at the end, and hope that you can get most of your questions answered at that particular point. Well, I can't help but feel a little bit sorry for pine warblers that might arrive a little too early in the spring. That's a bird that, of course, is a warbler. It's a bird that feeds primarily on insects that it gleans from the tops of primarily pine trees, but it will move around a little bit and occasionally will catch flying insects as well. But what we're seeing increasingly now is that more and more of our birds are arriving back out of sync with the weather. And that's simply one of the problems that we're going to be exploring tonight in a little bit more detail. So why should we worry about climate change? For those of you that have been following this particular issue more carefully, I want to review a little bit here at the beginning. Many of you will have some of this information already, but I think it's important that we set the stage so that we know what we're up against. So 2019, which we just completed, was the second warmest year in 139 years of record keeping. It was exceeded only by 2016, slightly warmer than 2017 and 2018. Likewise, the decade of 2010 through 2019 was the warmest decade on record. Probably based on information that can be gleaned from records in the ice caps, it may have been the warmest 10 years for some 56 million years. So the Earth is getting warmer, and it's getting warmer significantly, and it's happening very fast. Since 1980, the U.S. has had 241 weather-related disasters with a total cost of $1.6 trillion. Incidentally, weather-related disaster is $1 million or more, so we're not talking about the dinky little problems of a tree down on somebody's house here or there. We're talking about the biggie weather events such that we're seeing it with increasing frequency. So this is one of the reasons why our insurance rates are going to go up. They are going up because somebody has to pay for this. And we see this in terms of all kinds of the disasters, and we'll explore a little bit of those. But we see it in increased flooding, we see it with droughts, although we don't usually get it billed by the insurance company for a drought, at least not directly. But we're seeing it with flooding, we're seeing it particularly with wind, and we're beginning to experience it increasingly here in this part of the country. We happen to live in one of the most benign places that I can think of on the entire Earth. From the standpoint of climate change and how we're prepared and positioned to deal with it. But at the same time, we're going to see the kinds of storms and heavy snowfalls, early frost in the fall, things of that sort that will begin to have an impact on the economy in so many different ways, including what we pay for food in the grocery store and what we pay for pay the insurance company. Continuing with the reasons why we should worry about climate change, atmospheric carbon dioxide reached the highest level this year, and in fact right now it continues to go up daily, in 3 million years. That's pretty good data because that's based on very precise measurements of the carbon dioxide concentration in gas bubbles that have been trapped in the ice that has been accumulating annually in the major ice caps such as in Greenland and so forth. For the first time in human history, global rainforest this year went from being a net CO2 absorber to a net CO2 emitter. Most of that is because of the cutting of the rainforest, but the rainforests are being cut and burned, and that carbon is there going back into the atmosphere. That rainforest, which was a big absorber of carbon dioxide from the atmosphere, therefore is not there to do that work. Moreover, we have a lot of fires this year. You're certainly very familiar with that if you've been following the news at all. Particularly, we see a lot of that in Australia right now, which is seeing some of the worst drought that it's ever experienced, and a consequence in the fire that's burning through so much of that country. And that's putting both particulate matter into the atmosphere as well as carbon dioxide, of course. And then the 2019 study concluded that the North American continent has lost nearly a third of our birds since 1970. So the birds are reflecting some of these kinds of impacts and changes that we're seeing in so many other parameters, which we'll explore. So why do we worry about changes in bird populations? Well, birds have a much higher metabolism than we do, and they reflect changes in their environment far more quickly as a result of that. Secondly, they are much more intimately related to their environment. They're out there. They don't have an air-conditioned house or a furnace-heated house to escape to in the day or during heavy storms and so forth. Many of them have to migrate, some of them for thousands of miles from South America to North America. They have to find their food in the crevices of trees and on the limbs and branches and so on. So they're very, very tied into the community in which they live. And so they are much more going to quickly reflect any change in their environment and their habitat. And then finally, U.S. Fish and Wildlife Service estimates that over 100 million, actually I think the figure is closer to 110 million now, Americans watch birds and spend some $41 billion a year. This includes travel and restaurants, business and so forth associated with people that move around a lot to see different birds, but it also includes the binoculars and things of that sort which are spent for people that are interested in birds. This is the most popular outdoor activity in the United States. And so obviously we're interested in birds. We get great pleasure from watching them. And if for no other reason, we might be concerned about what's happening to birds. And so I think that belongs on this particular list. So if we go back a little bit further, the National Audubon Society commissioned several scientists to do a very thorough study of what was going on with birds. We've known for a long time. We've known since about roughly 1960 when we began monitoring bird populations very, very carefully that the bird populations are going down. But the rate at which the bird populations are collapsing is increasing, just as the carbon dioxide level is going up at an increasing rate, and we're seeing more severe storm damage at an increasing rate and so forth. Bird populations are going down at an increasing rate. So again, they're reflecting the very things we're talking about with regard to climate change. The study concluded that if we continue with business as usual, and incidentally, don't let anybody kid you, we are for the most part. We've made good headway in several areas, but we are continuing to fall further and further behind the curve when it comes to trying to correct the problems of greenhouse gases in our atmosphere. And so if we continue on this track, and I'll show you more data about that in a minute, it's estimated that 188 North American species will be threatened by climate change by 2080. What does threatened mean? It means they're on the edge of extinction. And so those are species that once they're lost, they're lost. Extinction is forever. And so that's something that we can't retrieve. Another 126 will be in danger. That means we have to worry about them, and they may not survive forever, but at least they're still extinct, or they're still present in some capacity or in some area. So a few of the headlines. The Baltimore Oriole will no longer live in Maryland. It'll be gone. The common loon may no longer haunt the waters of Wisconsin and Minnesota. Pretty good projection. It's not going to be here that much longer. It will be in Canada, so this is not one that's going to go extinct. And the trumpeter swan may no longer exist. It's on the edge now. So, studies and summary reports consistently remind us that birds may be an early indicator of the terrible toll that climate change will exact on biodiversity. And we'll expand that a little bit. But the literature is just filled with study after study after study, not only on birds, but on virtually every form of life that lives out there in the greater world. So, how serious is it if we, meaning the entire globe, fail to become carbon neutral by 2050? Carbon neutral by 2050. A tremendously challenging goal that we face. There's a 93% chance that average global temperature by the end of this century will increase greater than 4 degrees Celsius. That is a shocking figure, and you'll see why in a second. And near certainty that it will increase by at least 3.2 degrees Celsius above pre-industrial levels. That's the reference point. That was Nature. Nature is one of the leading scientific journals in the world today. And so these are not random numbers or somebody just speculating. This is based on very critically peer-reviewed data. To put that in perspective, the last time the Earth was an average of 3 degrees Celsius warmer, remember, we're looking at least 3.2 by 2080. 3 degrees warmer was 3 million years ago. And the conditions that existed in the Earth 3 million years ago is quite different than what we see today. But the reason for the fact that we're not there by any means, the conditions that we saw 3 million years ago, is we're changing the temperature and the carbon dioxide, the greenhouse gas level so fast. And the world is so big, it's such a huge system that has all the built-in feedback loops and so forth, that it takes a long time for it to kind of catch up. But it will catch up. This is the International Panel, or the Intergovernmental Panel on Climate Change recently concluded that while even a 1.5 degrees Celsius increase will result in huge problems of the kinds of things that we're beginning to see now, especially for coastal cities and low-income communities. It's low-income people that will pay the biggest price for climate change. Its global flood damage alone is estimated to cost $10.2 trillion by 2050. We might find ways to live with it. Incidentally, where do you suppose that $10.2 trillion is going to come from? It's going to come out of our economy. It's going to come out of our pockets. It's going to show up in our insurance bills and so forth. A 2 degrees Celsius increase. We're not talking 3 now. We're talking 2. And remember that the Intergovernmental Panel says that 3.2 is almost certainty. A 2 degree increase, according to the Intergovernmental Panel, is in their analysis would be devastating. Very, very difficult for us to deal with without a complete overhaul change in terms of our standard of living and the way that we interact in the world today. More disconcerting, the carbon dioxide level in the atmosphere back then, back when 3 million years ago, was only 360 to 400 parts per million. Again, hard data for that. This isn't speculation. We're already above 412 parts per million. So our carbon dioxide continues to go up very fast. And of course, as you realize, I'm sure, the carbon dioxide really is the primary greenhouse gas. We have others such as methane and so forth, but carbon dioxide is the one that's really driving the climate change primarily. And so if we look at a couple of things here, if we look at where we are right now, or where we are projected to be by 2050, I should say, we're projected to be at 1.8 degrees Celsius, based on these models. And you can see how well the data fit the model. You can see that this is the actual measured carbon dioxide level in the atmosphere, so those are hard data. These are actually global calculations of the temperature of the Earth. These are hard data. And so the projection then is this carbon dioxide curve here, which you can see is going to be somewhere over 600 parts per million by 2075. And that will drive that temperature up somewhere by 2075 in the neighborhood of 2 to 2.5 degrees Celsius. So we're going to hit that 2 degrees, almost certainly. Unless we could somehow turn this CO2 off. And although we have the technology and we have the knowledge to do it, we do not appear to have the will to do it. So the kind of problems that this is creating, it's not the increase in temperature. I mean, we can all tolerate 2 or 3 degrees Celsius higher temperature on average. That's not going to affect us. But what that means when we look at it over the entire globe are changes in the climate. It's climate change. We call it climate change for a reason. It's not only long-term change, it's also a much more complicated system than just looking at what the temperature is outside. And it's a system that's based upon the amount of moisture that's getting into the atmosphere. The fuel in the atmosphere is moisture. That's like gunpowder in the gun. And so the more moisture we put in the atmosphere, the more energy there is there. And that energy comes out in high winds, it comes out in intense rainfall, and that water has to come from someplace, and it comes from some areas of the earth where we have more severe droughts and so forth and so on. So it's a very complex system. And it's a system that we understand pretty well right now. But one of the consequences of the increased temperature, global temperature, is that we're seeing weather becoming more variable as well as more extreme. And I just use a couple of examples here. This is in Africa. And in Africa, incidentally, we now have something like 250 million people that have inadequate food in there on a daily basis, for example. Partly of that's due to extreme droughts associated with climate change. But at any rate, in this particular example of Africa, what we're looking at here is this line right here. That line is referring, you can see the red line, and it's simply a black line fitted to that red variability. This is the increased variability of rainfall in this area of Africa. And you can see that the average rainfall has actually gone down. That's a 10-year running average in the green line. And you can see that as rainfall has gone down, it's also become more variable. So there's more droughts and more heavy storms, and they're less predictable and so forth. And so that lack of predictability creates problems for birds. It creates problems for farmers. And it creates problems for us in a very minor sort of way. Do we take the umbrella or not? Do we have to worry about a flood in our backyard or not? So that unpredictability shows up in so many ways, but it doesn't affect us anywhere near like it affects the birds and the critters that have to be out there living with it on a day-to-day basis. This other example comes from the United States, and that's looking at the runoff in a particular basin. This particular basin happens to be in California. And these are hard data based upon actual measurements of the flow through the river that drains a particular watershed, a particular basin. And what we can see again is that although there hasn't been very much change in this particular example in terms of rainfall, you can see it's quite variable. And that's exactly what the models tell us, is that it's going to become more variable over time. This again is looking at the statistical variation, and you can see that the statistical variation, which you can't see with the unaided eye, these are statistically calculated, has gone up. So again, more extreme variability, less predictability in terms of how much rain we're going to get on a particular year, when it's going to fall, and the volume that is going to be released, and so forth. So again, it makes difficulty for farmers, it makes difficulty for urban managers that are trying to figure out how much money they need to set aside for snow removal. It makes problems for our infrastructure of trying to have enough sized culverts and so forth to handle the runoff. So the problems begin to show up in all kinds of ways that we often don't think about. Bringing it back home, if we look at ice on and ice off of Lake Mendota in Madison, we see that we've lost on average about 2 weeks in terms of the time when the ice forms on the lake and when the ice melts from the lake. So we're warming up. We're warming up. That's what that data is telling us in a very, very clear way. And these data go back to 1850 or so. People have been monitoring that for a long time. So as climates change, so too does habitat. And this is beginning to get to why the birds are so heavily impacted. In Wisconsin, based upon the best models that are available, winters will average 6 to 11 degrees Fahrenheit warmer with 15 to 30% more precipitation. Now what does that mean? Well, warmer winters and more precipitation means more of that wet, heavy snow, the kind that you don't like because it's hard to move, it's hard to shovel, and it's hard to get around in. Less good skiing conditions, for example. More water runoff in the spring when it melts, so more flooding probably. Summers will be 8 to 18 degrees warmer with more extremely hot days and 20% less precipitation. Hotter, drier summers. Growing season, not good for farming, not good for food production. If we look at the number of days that are over 90 degrees, I can remember, I can usually count on one hand easily the number of days they get over 90 degrees. When I first came to Wisconsin in 1988, I think we had 2 days over 90 degrees that summer I was here. And I thought it was terrible because a day over 90 degrees here in Wisconsin feels really bad. Well, now we're looking at an increase of 20 to 22 days over 90 degrees as a result of the climate change. And then extreme storms with heavy precipitation more likely in all season, but especially, of course, in spring and autumn. And we already are seeing those things. So, some of the predictions in terms of habitat change, paper birds, balsam fir, and white spruce will no longer occur in Wisconsin by the end of the century. Hard to imagine, isn't it, that these species, which we just take for granted as part of the particularly northern Wisconsin forest, will no longer be here. We will become a much more oak hickory, the green here, in the projection of 2070 to 2100. That green is oak hickory. That's the kind of forest that we see down in the southwestern corner of the state. with a lot of oaks and hickories and so forth. And we would lose primarily the birch and aspen forest and maple forest that now dominate a good part of the northern part of the state. So, over 60% of the 305 common bird species that overwinter in North America have shifted their winter ranges further north. 305 species. We're not talking about large numbers here. If we look at the average distance, we're looking at maybe 20, 30 miles of shifting north. But we're seeing lots of examples of that, and I'll give you some specific examples in a little bit. Similar studies in Europe show that virtually every life form, every animal form that you can imagine is shifting their ranges further north. Dragonflies, spiders, woodlice, butterflies, birds. And again, we're looking in that 20 to 30 mile shift to the north. So again, organisms are beginning to reflect the growing thermal warmth, particularly in the wintertime, where they don't have to move as far south as they otherwise would in order to survive or overwinter. Again, not a particular problem, except that these range shifts create problems. And I'll give you several specific examples in a few minutes. But a recent study suggests that the distinction between native and alien no longer means what it used to, because species now are moving around and now are getting into different combinations and different relationships with other species than those with which they evolved. And that's happening very rapidly. Evolution is a slow process, and we're talking about things that are happening on the order of a few decades now. So, some examples. This is data from the northern cardinal that was banded at the Mahomet birding station in Massachusetts. And what you're seeing now is that a very striking increase in the number of cardinals that are coming through that station in the fall and in the spring, both. What's that mean? The cardinals are moving north. If you were here in 1900, by here I mean in central Wisconsin 1900, you wouldn't have cardinals. There were none here. They were barely into southern Wisconsin in 1900. Now it's one of our common birds on our feeders. They're moving north. They're found in every county in Wisconsin now. So this is one example, a familiar example, of a bird that's responding to change in climate. In addition, we're seeing other birds moving north. Red-bellied woodpecker, tufted titmouse, we're beginning to see those that are feeders now, and the Carolina wren. Occasionally we pick those up now, even in the wintertime. This study was done on the ruby-throated hummingbird, the only hummingbird native to this part of the world. And they are arriving on average about a week earlier than they were historically. And again, these are hard data based upon observations of when the first birds arrived back. So they're coming back earlier. Remember, the hummingbird is very dependent upon insects, which it feeds on heavily during the breeding season, and on flower nectar. And so if it comes back and is out of sequence with blooming of the different flowers that it utilizes or the insects that it depends upon, this is a bird that's going to be in trouble rather quickly. A study that was done by Nina Bradley, Alda Leopold's daughter, and Carl Leopold, his son, and then others at the Leopold Center, was done in 1999, in which they looked at the phenological, the timing sequence or the time of the year when different birds arrived back and different flowers, wildflowers bloomed. Leopold was a great observer and a great note taker, and he took very careful data of this over a long period of time back in the 30s. Well, they pulled that data out and they began to look at it in today's situation. And what they concluded is that if you look at the time at which the various migrant species return to Wisconsin and the average time when different species flower, we are actually having spring about 0.12 days earlier each year, and that's based on the 61 years of observation. That is an incredibly fast rate of climate change. And again, I can't emphasize that when we look at these kinds of changes historically, that kind of change would have occurred over many centuries, if not thousands of years. And here we're seeing it happen in a matter of a few decades. And so the probability of migrating birds returning in the spring and encountering a late frost or a late snow is increasing. So here we have examples of the berry thrush and then bluebirds and robins, which we're all familiar with. It's not too unusual to see bluebirds and robins here in the snow. And the reason for that, and it's becoming increasingly common to see them in the snow, but the reason we often see them is because they're not true migrants. They only move as far south as they need to in order to find enough food to get through the winter. Well, they're not going as far south now, and they're coming back earlier because the spring is warming up faster, and the probability of getting one of those late frosts or snowstorms is increasing. So those are some of the examples of birds that might be heavily impacted. When we look at migration, we see other problems that we can't excuse or we can't dismiss either. If we look at what's happening in terms of our overall landscapes, we see that we're creating all kinds of other problems for migrating birds as well as local birds for that matter. Whether it's the pesticides on our crops or whether it's clear-cutting forests or the cities that now dominate our coastal areas, birds flying across the Gulf of Mexico for maybe 20 to 30 hours non-stop flight arrive now, and instead of a nice tree to land in where they can glean for insects, what they confront increasingly on the Gulf Coast is this. And then, of course, wind farms and lots of other challenges that we've put out there that are beginning to affect the birds. So when we talk about the birds decreasing by 30% since 1970, it's not just climate change that's causing that problem. It's climate change plus these other exacerbating conditions that are increasingly affecting the birds in various ways. And some of these are indirectly related to climate change, such as the wildfires that we're seeing. Have you heard the figures about the number of wildlife that have been killed in Australia? It's staggering. We're talking millions and millions and millions. And so where we're seeing these widespread fires, where historically they're only small or local fires or light fires, that's a huge habitat change. And there's going to be direct mortality in addition to the habitat loss associated with those extensive fires which come as a result of more extreme drought. Floods are also increasing, and mostly we worry about floods because of the damage to our infrastructure and the inconvenience it causes us. But there is a lot of direct damage to the birds as a result of floods, not to mention other critters as well. And so we find nesting loons and other species that might be arriving back to begin their nesting and suddenly discover that the habitat which they ordinarily would, where they ordinarily would build their nest is flooded and no longer accessible to them. Numerous studies have now shown that insects have declined globally by 40% or more and are decreasing by an average of 2.5% per year. That is a figure that should scare the heck out of us. The insects are so critical in terms of maintaining balance of nature, but they also are an important source of food for so many of our bird species, and as well as pollination. So those two primary things there alone is enough to cause great concern about what's happening to insects. And incidentally, this isn't one or two studies. These studies have been done around different areas of the world. And so the loss of insects may be even more critical in terms of telling us what's going on than the decrease in birds, but the two are very much the same. They're telling us the same story. So some of Wisconsin's summer species that will no longer nest here by 2080. 2080 gives me very little comfort. I won't be here 2080, and neither will most of you. But our children and our grandchildren will be here. And it's hard to comprehend the kinds of problems that we're leaving them that they're going to have to deal with. So, some of the birds that will no longer be here, one of my favorites, the golden winged warbler. The black and white warbler will no longer be in Wisconsin, the ruffed grouse. American redstart, the one we mentioned before, saw-whet owl, chestnut-sided warbler, and the white-winged crossbill. These are birds that, some of which, like the crossbill, are getting very rare now. You can go up into northern Wisconsin sometimes and find one or two, but they very rarely can be seen around here. Some of our most iconic species will no longer be common, if they're here at all. Bobolinks. I used to have bobolinks around my house because I live in the country, and they would come in and they'd sit in my orchard and sing from the top of the trees. I haven't seen a bobolink in some years now. So this is an example of a species that's decreased 50% since 1970. Some species will become more common in the winter, so it's not all bad news, I guess. But the ring-necked duck is certainly going to be increasing. Common grackle, the common snipe, ruby-crowned kinglet, and the yellow-bellied sapsucker. Yellow-bellied sapsuckers we occasionally are seeing now in the wintertime. I haven't seen one in the winter, but people are beginning to report them. So these birds are going to become increasingly common in the wintertime. And some of the more southern species will begin to nest in Wisconsin. And this is, I guess, the good news is that those that have been more southern in their distribution are likely to move into our area. That would include the Kentucky warbler, the planetary warbler, and northern mockingbird, which we're already beginning to see in our area here. Now, one of the problems that some of the birds have, and this is not just birds again, it's all species, is that those that live in the far north or at high altitudes have no place to go. The birds in Kentucky can move up to Wisconsin. The birds that live in North America, such as the snow bunting, which is one of our favorite winter species, which we're seeing increasingly rarely, nest right up here along the Arctic coast and on these offshore islands. There's no place to go. They can't go any further north. And so as the climate warms, they are stuck, and their population will decrease accordingly. This is also true, and we see this throughout the world, of species that utilize those habitats right up near timberline and so forth. They can't go up into the areas above timberline, and so they have no place to retreat. Now, a good example of some of the kinds of problems that we're beginning to see where species ranges are changing is illustrated by these two birds. I've already mentioned the golden-winged warbler, one of my favorites, and a very closely related species, the blue-winged warbler. These birds both utilize very much the same habitat. They both like these deciduous, brushy habitats, the kind of habitat that's created when you clear cut a deciduous forest, for example. And so these species increased rather dramatically when we begin to clear the primeval forest and replace it with farmlands and the timber industry and so forth. Well, it turns out that although they're very, very similar in many respects, they'll even interbreed under certain circumstances, the golden-winged warbler is a much more aggressive species. And so the golden-winged warbler, as shown in blue here, is moving north, and the blue-winged warbler. The golden-winged warbler is in the yellow and green. Green's where the two species overlap. As the blue-winged warbler has moved north with climate change, it's pushed the golden-winged warbler increasingly out of its preferred habitat, the deciduous type forest, into the boreal spruce fir type of habitat, where it no longer can get the resources and so forth that it needs. And so what we see happening, therefore, is this is the population trend for golden-winged warbler. Another species that will be extinct probably within my lifetime, certainly in our area. I could probably go up into northern Minnesota and find it for a few years yet. But this is a bird that's on its way out as a result of these shifting distributions of species and changing competition and relationships between species. Think about all the relationships that are out there, all the predator-prey relationships, all the competitive relationships, parasites and diseases, and the list goes on and on about these very intricate and extremely evolved relationships between species that are suddenly being shuffled as a result of species moving from one area to another. Well, this is a picture that was taken I think it's now 2 years old or 3 years old, on the Oregon coast. And it's a graphic example of telling us that something's wrong. Something is wrong. These caissons auklets are washing up on shore in large numbers, hundreds, thousands of them, being picked up with a bushel, a truckload. And so it raised a question for the scientist, of course, is to figure out what's happening out there. Well, a little bit about the bird. This is a relatively small bird that feeds in a marine environment. And by small, I'm talking about a bird about the size of a quail or something like that. The distribution of the bird is primarily right along the coast, from the Aleutian Islands all the way down to the Baja Peninsula. So it likes these coastal areas. It'll go out to sea to feed, but it nests obviously on the shore and so forth. And so when they examined these auklets that they were gathering along the beach, they found two things. Most of them were juveniles, and most of them had starved to death. So something was causing these birds to starve to death. Incidentally, it wasn't just caissons auklet that they were picking up. I'm using this as an example, but there were several species of these shorebirds that were washing up on the beaches. So we need to study, or need to know a little bit about the oceans in order to figure this out. And this is an area where, in my opinion, we've most neglected the impact of climate change. We have, to an incredible extent, just ignored what was happening in the oceans. And the caissons auklet is a grim reminder of some of the kinds of things that we ought to pay more attention to. So we know that the oceans circulate. These great big circulatory currents occur in each of the major ocean basins of the world. The one here in the North Atlantic we're probably most familiar with because this is the Gulf Stream that comes up along the east coast of the United States and turns a lot of our hurricanes up to the north so that they don't come inland and impact those of us in the interior of the continent, for example. More importantly, perhaps, in some respects, is that as the Greenland ice cap melts, it's dumping a lot of cold water into this North Atlantic jarret. And that cold water is now being carried back toward the tropics where it gets formed and then circulates again. It takes about 5 to 10 years for this circulation to occur. So it's a very slow process, although we're talking about big distances here. If we look at the North Pacific, we're looking at a very similar phenomenon. Notice things are moving clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. That's the Coriolis effect that causes that. But this Pacific current takes about 15 to 20 years to circulate, so it's bigger and slower in some respects. But what the importance of these ocean currents is, that we're talking about here, is that they're carrying the heat, which is being loaded on the Earth primarily most intensely along the equator. They're carrying that heat to the north and to the south, toward the poles. And if it weren't for that, we would have a much more extreme variation in weather or climate over the Earth. The poles would be a lot colder and the tropics would be somewhat hotter, particularly those associated with the ocean. So these ocean currents are very important. They are major determinants of weather patterns, for example, and in a complex way that we don't very well understand. But again, most of the heating on the Earth occurs along the equator in the lower latitudes. And at the same time, you're aware, I'm sure, that the poles are being most impacted by climate change because they're cold climates, and so a change of a degree or two in those climates makes a big difference. Another degree or two in the tropics doesn't seem to affect those species so much. So what we want to call your attention to is primarily this North Pacific gyre that we see here. And what we now know, and this is now being reported finally, it's been a little tardy in being reported, the UN report recently released shows that the marine heat waves are occurring with more frequency and greater intensity and are lasting longer. In other words, the heat loading in the ocean is actually occurring, but it's occurring in a much more variable way, not in a regular systematic way, but in a much more variable way. But that increased heat is being reflected here in the climate in the North Pacific and down along the Gulf of Alaska and all the way to Mexico. And it's being reflected by warmer temperatures because we're putting more heat in at the equator, and we're doing it with greater intensity, although somewhat more variable. And then the current is carrying that warm water all the way around that North Pacific gyre in a way that is changing the climate for the marine organisms. So this takes us to another group of species, krill. You all have heard about krill. Krill are the small crustacean shrimp-like critters that live in large numbers, big schools of them where they occur. And this is the primary food for the baleen whales, for example, including the great blue whale. But it's also a primary food for a lot of birds that live in the ocean where the krill occur. Well, krill, you can see the size of them. They're very small. There are about 85 named species, probably more, but 85 that have been named. They occur in all marine waters. They feed on phytoplankton. So this is part of this is the second step of the food web, if you will. So the phytoplankton are carrying out photosynthesis and fixing carbon, and then the krill pick it up, and of course they reach large numbers. They can reach these almost unbelievable concentrations. And they're very sensitive to water temperature, but also to pH and pollutants. So what is happening then to the birds? The krill move deeper. So as the surface water of the ocean warms up, the krill go down a little bit deeper where it's cooler because they're very sensitive to that. Even a degree, even a tenth of a degree will cause krill to move. And so as they move down, the young auklets can't dive that deep to feed. They're up near the surface. They're used to feeding within a foot or two of the surface. And so they're just simply not getting enough food, and they're dying and washing up on the shore. And that's happening to a lot of the birds in the Pacific and probably elsewhere. It's just one example of many, many of the changes that are taking place in the oceans that are going to have an impact not only on the birds, but on the fish, the price that we pay for fish in the market, the amount of, the number of people that have inadequate protein in their diet, because fish is a major component of people's diets in many parts of the world. But the story gets worse from here. These are examples of pteropods, a broad class of zooplankton. Zooplankton are microscopic. This is a 1-inch scale that's shown right here. And these are these organisms. So you're looking at something like a tenth of an inch, maybe for most of these, that's their size. But they all have carbonate shells. These are organisms like a snail or like a mollusk, but they're almost microscopic, and they have these carbonate shells about them. And they are the second step in this food web that starts with phytoplankton, zooplankton, and then on up through organisms all the way up to the salmon, to the cod, and to all those top predators that are in the marine environment. So if something happens to these base components of the food web, the whole web is endangered and could collapse. I should go back here a second if I could. I wanted to point this out. When carbon dioxide is dissolved in water, the red formula at the bottom there shows you that. When carbon dioxide is dissolved in water, it forms a bicarbonate molecule, which disassociates into hydrogen ion. This is carbonic acid. And carbonic acid is a weak acid, but it disassociates, releasing the hydrogen ion. And that hydrogen ion is the acidic part of the ocean. And so this reaction is going on. But that carbonate ion also reacts with magnesium and particularly with calcium, among other things. And it forms carbonate precipitate or carbonate shells for krill and more importantly pteropods in the example that we're talking about. Anything that has one of these hard carbonate type shells. That material tends to precipitate directly or indirectly. It could go through a food web a few times, but it ends up and down in large sediments, accumulations on the bottom of the ocean, and that gets compressed into limestone. It is a major way in which carbon is taken out of the global ecosystem. And so if something happens to break that cycle down and to disrupt that, then it's simply another one of these places where we can change the environment in a way that it can no longer protect itself from the damage and changes that we're causing as a result of putting more carbon in the atmosphere. So by the end of this century, the oceans will be twice as acidic as pre-industrial times, twice as acidic. This will happen even if we cut carbon emissions by half in the next decade. We're not going to do that. We'll be lucky to cut the carbon emissions half by 2050. This result will be hundreds, perhaps thousands of tiny marine organisms, those that produce carbonate shells, from going extinct and crashing populations of surviving species. This itself will increase carbon dioxide in the atmosphere. So this is one of those feedback loops that we rather didn't happen, but it is happening. We now know that it's happening. A study published in 2010, again in Nature, one of the leading scientific journals in the world, reported that phytoplankton have been declining about 1% per year and have decreased in the northern hemisphere by 40% since 1950. Remember those phytoplankton? That's the primary producer in the marine environment. Those are the organisms that the zooplankton eat. And those are the organisms that the other trophic levels eat, all the way up to the fish that we enjoy ourselves. So, some of the reasons that climate change is stressing birds. More birds are arriving in the breeding habitat out of sync with the environment, out of sync with climate. We're seeing examples of it almost on an annual basis now. Large numbers of dead birds is not too unusual with an unusually hard fall frost or a late spring frost now. We're seeing that as ranges of birds change, they are put into conflict in ways that they're not adapted to. Conflict with other species, competitive conflicts, exposure to parasites and diseases, and the list goes on and on. Climate change causes related species to die off and move or decline, and triggering a cascade of changes. And so what's happened to the krill is affecting so many different species, but many of the marine birds in particular, but many fish species and others as well. And in this case, we're just talking about a minor change in the depth that the primary krill are located. Habitats for many, perhaps most bird species, are either being reduced or compromised by human activities exacerbated by climate changes. And so, again, we're seeing the fires and the pesticides and the droughts and so forth that are having an impact. Meanwhile, our president is taking steps to reduce or eliminate the carbon-reducing policies. And so the cartoon kind of says it all. The canary died, kick it down the road. We'll put it off. We're not going to worry about it. We'll let another cycle go by here before we get serious about climate change. I'd be happy to take any questions or comments. Don't all raise your hands at the same time. Anyway, Ken. I do Ken.
So a change in political atmosphere is one of the key changes we have to worry about. And I'm not going to take any political sides, but we know that right now not much is being done by the current administration for the environment.
Well, I would put it differently, Ken. I would say what's happening by the current administration is increasing the problems. It's almost devastating, the problems that the current administration is causing, which are going to have impacts for 100 years and beyond. So, you know, we can't put back some of the kinds of negative things that have happened. We can fix things like, you know, gas mileage in our automobiles and things like that. We can fix those pretty quick. But we can't put forests back where they were removed. We can't put oil back into the ground. We can't put coal back into the ground. And that's some of the kinds of problems that we're looking at.
I'm glad you mentioned the marine environment as a major part of your talk. Thank you very much.
You're welcome.
One thing I'd like to emphasize, in addition to all of your fine work here, is that coral reefs are very much endangered, and your equation is absolutely right on. The carbonic acid H2CO3 is dissociating into a weak base and a strong acid. The gist of it is that hydrogen ion that you were talking about, that is the acid, is dissolving and working on the skeletons of corals. And a lot of corals have now become bleached, which means dead, and they're just a white skeleton of what the animal used to be.
And I don't know what, Ned probably knows, I'm not sure of the figure, but it may be as many as 50% of the marine species.
That's what I had heard, 50%.
Have their reproductive, a part of their reproductive cycles tied to coral reefs. So coral reefs are very critical to maintaining diversity of the oceans. And we're probably going to have lose 80% of the coral reefs by 2080. They're going down fast. And that again, we're talking about something there that's going to take 1,000 years or longer to fix if we ever fix it.
Tremendous biodiversity.
Tremendous biodiversity, yeah. Other comments or questions? Yes.
What about oxygen? The forests are kind of like the lungs of the planet, and then, if I'm not mistaken, the phytoplankton also produce an awful lot of the oxygen. And you were talking about the phytoplankton declining and talking about the deforestation that's taking place. What is that doing to the oxygen in our atmosphere?
I don't know the answer to your question, but I can give you a generalization as an answer. The generalization is that the amount of oxygen in the atmosphere will be going down slightly. And it's going down slightly because as we fix carbon in the form of organic matter in the soil or organisms swimming in the sea or whatever, as we fix carbon, meaning we're taking carbon out of the atmosphere through photosynthesis and fixing it in the form of the biomass of living organisms or their end products after they die. We release a little oxygen. And so as these organisms are impaired, then we're taking a little less oxygen, or we're putting a little less oxygen into the atmosphere, that's what it means. The difference, however, would be so small. I mean, we're looking at, what, 18% of the atmosphere that's oxygen. So if we reduce it by 0.1%, that's just, I mean, you would notice that if you went to the top floor of a 10-story building. So we're looking at relatively small impacts of that oxygen in terms of atmospheric oxygen. Compared to the carbon dioxide, which is a rare component of the environment, which if we increase by 100th of a part per million, we would notice it. So the difference is simply quantitative, and your observation is entirely correct, I think. Okay.
Are corals the major source of oxygen in our environment?
I don't think corals themselves are, because corals are animals, but the organisms associated with them, they would be very important, very important. Not only that, the corals protect our coastal areas against erosion in a very significant way. We don't think too much about that because we're a long way from the ocean, and in the northern latitudes, coral is not very important. But in the tropics, coral is a hugely important group of organisms that protect those coastal areas from erosion. And so they play more than just a structure in which many aquatic organisms can reproduce, including algae that, as Kim is suggesting, contribute to the biomass production. Yes?
As an individual, besides throwing out the current administration and getting people who are more friendly to the environment, what can we do as individuals?
Yeah. Well, my guess is that Ned or Kent or Dan, any of you guys could probably respond to that better than myself. I can give you things that I do, but I think the one thing that I would say is that if we're going to achieve the kinds of reductions in carbon that we're talking about needing to achieve, we have to change our lifestyles. We have to change the way we live. I feel guilty driving in here tonight. Because every time we jump in a car, every time we open a refrigerator door, every time we turn a light on, or worse, leave one on that we're no longer using, we're putting carbon into the atmosphere. And so I think that we don't want to give up the way of life. We live pretty darn good, particularly compared to the vast majority of the world. But we also our carbon footprint is the highest in the world as a result of that. And we're very reluctant to give that up. We're going to have to give it up. If we don't, our children will simply pay a bigger price.
Can I jump in on the answer to that question too for just 2 seconds? You can look at the list of people who are sponsoring, organizations who are sponsoring this event. There are things that all of us in this room are doing. A variety of things that we're doing to deal with limiting the amount of carbon dioxide that we're expending into the atmosphere. And those are important, those are significant, those are worthwhile, and those are insufficient. In order for us to have a major impact on the environment, we have to have some legislation in the federal government. And that's what Citizens Climate Lobby has as our primary purpose. We have legislation, bipartisan legislation, I should mention, before the Congress right now that would enable the amount of carbon in our atmosphere to be reduced significantly by 2040, 2050. Is that all that would have to be done? One bill passed? No, but it's a first step. I'm here to urge you all to get involved. Keep up doing what you're doing as individuals, but also join with others in this room and in this city and state and country to bring an end to the constant emissions of carbon dioxide that are destroying our climate and our atmosphere.
Incidentally, before we depart here, I wanted to again call your attention to the Jewels of Nature, which is essays about local birds that you will see in your backyards. They're on the table here. Laura Hagen will take your $15 for any of the books you might want if you don't have one. They make great gifts to people that are interested in some of the problems that we've been talking about, or just interested in birds. And all the money goes to the local Audubon Club, which does a lot of good about conservation and protection. So, yes, sir.
Yes, I was kind of wondering if you could help us a little bit. You know, I hear a lot of this about, you know, the new Green Deal, and then I'm hearing the Blue Deal. Also, you know, can you kind of give me a perception of what you might think would be like major projects that would really clean this up, or what they are talking about when you say Green Deal or Blue Deal, and you know the whole concept?
I think the number one thing is that we got to get off fossil fuels and on renewables. Yes. We have the technology to do it, and if we did that, it would make a huge difference in terms of our impact on the global climate. So it's a matter of simply accepting that. Right now, we're bucking the political winds because they are protecting the fossil fuel industries. And we need to make sure, first and foremost, that we get rid of politicians who take those positions, and number two, those who are proposing policies to protect the carbon industries, the fossil fuel industries. They have a tremendous market advantage because of the incentives that are provided, not just by our government, but by governments around the world. Australia, talk about irony. Australia is the #1 coal producer in the world. And they're getting burned up because of the drought and the climate change that's occurring. They're beginning to realize it, but they're realizing it a little bit late. I would like to think that the United States is not going to be late.
What about the zero population growth, habitat loss because of humans that are encroaching on everything? India's population, Africa, encroaching on habitat. Aren't we lost unless we tackle the real key thing as humans are taking over the planet and leaving nothing else?
Population growth is a serious problem, no question about it. And it is a particular problem in areas of the world which are less developed. Developed countries like the United States are doing pretty well in terms of controlling population growth. But the #1 thing we might be able to do, that again we can do it, and that's educate women. Educate girls.
Absolutely.
Make sure every woman that is born has at at least the equivalent of high school education. Makes a huge difference in population.
I'm not seeing hands. Any other questions for Dr. Haney? Can I ask for another show of our appreciation? As I mentioned before, this is the first of the fourth Thursday climate forums. The second one, which was on a little card that disappeared down there, I was waiting for it to fall, and it did. Thanks very much. Second one will be on the fourth Thursday of February, and it will be with Dr. Paul Sletton, who is a physician in Waupaca, and he's also the leader of the Waupaca chapter of Citizens Climate Lobby. And he'll be talking about how climate change is impacting our health and the health of everyone else in the world. Then on the fourth Thursday of March, followed by the name of Chris Holman, who some of you may know as our county executive. He is also co-owner of Nammy Moon Farms. He is a farmer. I've heard his presentation on this topic. It's about farmers' challenges, climate, and more. It's excellent. So if you're interested in that, that will be March. And in April, Pat Drees, who is with us this evening, will be speaking about how best to reduce climate change. And that will be on April 23rd. Those are the first of a series. It'll be going continuously up until election month, November. One thing we can all do is vote. My Citizens Climate Lobby, Interfaith Community for the Earth, for that matter, and many of the other organizations sponsoring this event are nonpartisan. But we're not stupid. We will support the people who will preserve our climate and keep this a livable planet. And I urge you all to do likewise. Any of you interested in learning more about organizations, see one of us, we'd be happy to talk with you. Any other questions from anyone?
Dan, just to repeat what you said, don't just be an individual. Get connected with one of the sponsors.